Thank you, Anastas, Labas, everyone. Welcome to the second webinar. I will present to you in the second part of the webinar the Advanced Integrated Electrical CAD Design. DDS-CAD is a tool for the complete MEP engineer, not only electrical but also plumbing, heating, sanitary and ventilation. And of course the focus of this webinar will be done on the electrical part. My name is Gert-Jan Laurensen, and I will give you a short summary with a few slides about the first webinar. Because of the project we are going to use in this second webinar for the advanced part. DDS is an innovative software tool for making design in 3D. We started with a complete plan included with integrated light calculations, including safety lamps and safety lights. On the plan, in low voltage environments, we put in the fire alarm, the telephone, the KNX, and other safety indications. And from this design, we also saw the connection of the cables, and that will also be used in this second webinar. The cables will be planned on the routing systems, which are integrated in DDS, which will be the cableway or the cable path for the connecting elements from the distribution boards. So as a quick overview, those first slides will give you the setting on which model, which plan we are going to use during this webinar. So let's start with the live demonstration. I've prepared the project on my screen, and we will focus on cable dimensioning, voltage drop calculation, and also a little step into the automation on distribution boards and layouts. So if I open the plan, we can see for our low voltage system that we designed a data rack on the left corner in the mechanical room, and we would like to connect to one of the sockets inside one of the office spaces. And for this I set up a distribution board overview, which include with several sockets connecting to the data sockets. So for the internet connection or for the LAN connection. And what we can see is that included in the model, also the length will be calculated back to the distribution board. Now, if I extend my distribution board by selecting another circuit, we can easily copy the elements which are integrated and inserted into the model, and we can reuse the circuits. So in this case I'm putting in a 6-volt data network, and as we enter a next sheet in order to supply the information for the second element, we can see from the 6 available circuits that no length is calculated. So if I now make back the switch to my plan model, we can see there is one data socket not connected yet, and if we choose of one of the circuit layouts we have set up, then we can choose circuit number, cable number 7, and start drawing from the circuit. So automatically the information from the data network cable is integrated into the connection. So now the object will be connected, and because of the trunking, which will allow the cableway back to the distribution board, or the data rack in this case, we can automatically see that the cable is calculated with a length for this element. And this allows us to have from the patch panel list in the overview also the cable length visible on the report or visible on the screen, and also visible on the bill of quantity, which will be updated automatically. So when we create a complete part list, we can identify the network cable, and if we see the network cable, now the length of the cable will be included with this connection point. Also from the patch panel list, we have set up a layout from the distribution board included with the A1 component, which was the first 6 circuits defined. So right now there is a second object created with the number A5, and this can be integrated into the drawing, also for making plans in here. So let's see. So right now, so this is the board layout, which is a setup, and this setup can be created from, I will do it another way around. So I will enter my distribution board layout and I will generate the scheme itself. So if I took my A5 component and place it into my board, then I can generate also inside the board all components from racks, from connection, from joints, from cables, including with opening elements. And from the board I can generate the layouts. So right now in the overview, in the layout, we can see the circuit A5 and A1 included in the rack overview, not only in 2D but also in the 3D representation. And this is also something I will show you on a low voltage distribution board from the plan. So the connection and the link to the electrical schematical from the data rack is manipulated in the same way we do for the low voltage systems. In the first webinar, we created a complete light fixture based on a calculation inside this particular office room, and we connected with a cable also to the trunk. Now if we look and open the elements for the cable, we can see for our load data and calculation that the length of the cable itself is calculated back to the central, means distribution board connection over the trunking is calculating the exact length. The cable itself, so what we can see in blue, which is now selected, has a different cable length. And what we can see from this this dialog, we can see also the integrated voltage drop calculation for the entire length, and we can also see there is an option to a main central, meaning if we have multiple distribution boards, we can also connect and calculate the entire voltage drop calculation. So for this model, I will create a main distribution board which will be positioned outside of the building. This could be inside a building, and this will have the feed-in of the grid of the electrical system. Now inside this board, I will define the circuit list overview by creating new circuits. First of all, I will generate my supply based on a load and the phases we set on phase 1, 2 and 3. Within this macro, we will select what kind of fuse will be used to have the circuit breaker in the start of this distribution board. So we can have different overviews on circuit breakers and different representation. So if we have standard diode, or if we have standard horizontal fuses, we can make a selection out of it. So let me choose one of them as a setting on a D02 20 amps. So this will be the first board, the first circuit in the board, with the naming of the supply. Now the next feed or the next circuit will be the supply to the sub-switch board. So this is a special supply in which we can add the connection from one board to another board, also to have the load calculation and also to have an overview on the used phases. So right now I will take this one as a type C molded circuit breaker, 16 amp, and this will be the connection to the sub-circuit. Now within DDS we have the indication to what kind of circuit is defined. And if I select a normal socket, one-phase socket circuit, we will have a different representation inside. So right now the indication in gray means there is no cable connected from one element to another element, and this is something we would like to solve. So first of all, I will draw the grid cable from the main distribution board. So this cable comes or will move from the grid into the distribution board. like this. And from the main distribution board we will connect a cable underground to the distribution board inside our model. So we go along the path to get a connection to the main distribution board inside the building. As we can see, the main distribution board is recognized, and if we make the connection, we get a notification because of the load, because of the length of this cable, that the dimension which was initially chosen for the cable will not be sufficient. So based on the load we set up 58 amps. The cable in dimension itself will not be sufficient. So we need to either lower the load or improve or enlarge the cable dimension. So if I now choose a 10 millimeter cable, then we can see that the connection from the distribution board to the cable, also to the sub-distribution board, is now fully yellow, means everything is okay on this particular part. The indication in red, which are shown here on the device tab, will be handled later, because this is also depending on what kind of loads are connected in the sub-distribution boards itself. So I will place a cable marker to indicate this cable. Now if we switch back to the cable where we started, we can now see that the load of the cable calculation is not only according the routing of the light circuit connected to the distribution board itself, but also the voltage drop is calculated back to the main distribution board. So included with the cable length on the 10 square meters, or the 10 square millimeters. So the changes in the cable type will also include the changes here. Now for our volt drop calculation, we can identify that within the load of this cable, the total summary of the connected lamps will result in a nearly 2.5 amps current through this cable. And if we indicate that our switchboard cable, we can now see that the absolute voltage on this particular point is 224 volts. And if we show this for all the other components in this area, I will make a selection for just the lamps. And if I activate my text representation, including with this mounting height, then also the other elements will be visible for our volt drop. So the effective current on this particular lamp light fixture will be 1.89 amps, resulting in 223 volts. And accordingly, or in the routing of the path, we will see to the last light fixture that we will have a different amps. So this is the last connected lamp, resulting in nearly 0.2 amps. So on each step we can follow not only the current but also the voltage drop in volts, or we can activate also the voltage losses in percentage. So if we activate the Partex, we can see that in this cable, or at this point in the installation, we have the 1.7% volt drop. Now there will be some checking on this this cable, so we can see from the load and data tab that we are checking on a reference on 3%, and with a total of 1.79 to the main central, we are in line with what is maximum allowed. So let's do the same thing for some other circuits. So within the distribution board, distribution board 1, which was placed inside the office space, we can define another socket. So for us it's easily to take one socket and copy the entire circuit and start drawing the cable. Now if I start drawing the cable inside in my model, I can start from a cable ladder or a cable trunk. The cable ladder will be automatically created to a trunk, and if I now start from this trunk, I will get a notification that this will be a free cable which is not connected to a central, meaning I'm starting from the wrong trunk. This trunk of 100 mil is connected to the data network. So I can still start with a cable from this position, but then it will be not recognized for the entire connection for the cableway running to the trunk or the cable ladder in the top position. So right now, if I start my draw of my circuit, then this connection can be created correctly. So I will jump into my cable duct and go to my socket, and from my socket I will follow the cable path. Let's see, and make a connection to the different sockets. Let's see here. So in this case, I don't want to recognize the cable duct in order to create a trunk, but I would like to create a direct connection from one cable. Now this is the same message about the dimensioning. So because of the length of the cable is now increasing, we need to make an improvement based on the 1.5 square millimeters, which is now entered in here. So I will take a 2.5 and can continue my cable. So in this case, if we activate also the different representation, we can see that the load, which is set to 16 amps, and this can be visualized on many ways. So we can activate that from the configuration of the current, which is set up here, the current rating or the actual current. There is an indication for the load itself. So my nominal load or my nominal value is 16 amps for the circuit breaker, and the load will also be calculated to 16 amps. Now the result of the cable calculation itself, if we calculate this cable, then we will see, based on the installation method, the calculation will be done accordingly to 6 values, or six steps will be calculated. Not only volt drop itself, but also short circuit and the overload protection, resulting into a minimum of 1.5, and we can overrule this by using the cable dimension. And the cable itself can be calculated to a report, and the report will give the total information of this cable. So what is the nominal, what is the load, and if we see, for example, the second circuit or the second cable for the lighting, we can see the load in here, and in the report itself all settings are visible. So we can optimize the system when possible to have a different overview, when possible to have a minimized dimension. We can influence the entire system. So right now I will open up my electrical schematic for the main sheet. So initially we had the F10 as the end result. I made a copy to an F11, meaning that I can insert another sheet and automatically also the circuit diagram will be calculated and will be generated. And not only the single line diagram but also the multi-line diagram. So this consists on either the representation in an industrial format for automation, and as we can see, automatically the last circuits are inserted also here. From the layout overview of the distribution board, if we say look to the layout, we can set up from the main distribution board and place the symbol inside the model. And right now, remember that we had the different fuse settings. So if we draw from fuse 1 to fuse 5, we would like to start from this element and generate the fuse overview inside here. So right now we can move them, and if we draw the F1 to F2, then automatically the F3 will be the next selected fuse component to be drawn. So right here we will have the second row, and if we would like to create another one, we can also insert the last one, the F8, to maybe F12, and that can be inserted in here. So the F12 was not needed because we ended with the F11. So right now this board overview can be inserted in here and also be represented back into the front view overview and also the 3D overview for the components. Now, if we look to the single line diagram, then I would like to use a different layout for the macro, which is now drawn for a one-phase circuit, including with a contactor. So from the distribution board sheet, I would like to use my own layout. So we saw that from the installation part we can have different layouts, either with a protective device, or we can have different settings for control control layouts, or for lighting layouts. We will have different macros for connections to motors. So all of the components are defined as a layout, and the layout can also be influenced by ourselves. So if I take a next circuit to create my own user-defined layouts, I can include whatever I would like to have, which will also be included into the macro. So right now I'm defining a fuse with a two-way outlet, and this will be drawn onto my circuit. So the difference in representation, also in the overview for the automation, is if we can select not only what we have, but we can also select in a different representation that this board will be a socket, and the other components we defined as a light circuit. And this is also an object which is included in the call of the macro itself. So what we have for this circuit is a representation as a single circle. For the sockets we can choose the different representation in single line and multi-line diagram, and we can also change all of the settings for the representation we would like to have in our schematical diagram. So right now I'm creating my own diagram and also the representation how this should look like. So I will switch back to the active view. Now, selecting the circuit, I will use the option to edit the circuit itself. So now the circuit is editable, and the components I don't want to have can be deleted from here. So I don't want to have my terminal because I'm generating a different representation. So right now, if I insert another component, then I can use a KNX component for switching devices. So by adding a KNX, we can insert a 2-volt actuator, and in this way I'm using a 4-volt actuator on 10 amps, and that will be included automatically into this model. The representation for this sheet is done like this, and right here I would like to use my single channel right here. For the second circuit I'm using from the same KNX component, I'm using the second free channel. So as we can see right here, the first channel is already taken, and choosing the second channel we can use the option for inserting. So this will be done, and for the next component we will use a relay contact, which is a connector relay contactor. Let's with a 1 pole 20 amps contactor element. So this object is inserted in my circuit, and from the component list itself I can also insert a second contactor. Let's see in here. If I select show only used products, my listing will be generated to the easy way, also included for the manufacturer, for example. So that will increase also the speed in designing. So this is not the correct representation I would like to have. So switching to what we have like this. Now the routing of the cables can be done easily. So when I select this cable or this fuse, using some help lines, we can easily draw next of the circuit. So this is an intelligent line where you can continue from here to here, and if we start drawing from this component to this component, I will turn off like this, also from here to here. So this is a complete layout we are going to design in order to have an overview of the board. So from this endpoint, I'm selecting the projected endpoint. So this could be the manual layout I would like to use for my next design. So when applying this setting, we can say this is a manual inserted 1 pole protected device with 2x4 leads. Now this circuit will be updated and will be applied into the model itself. The advantage for this is that the components will be automatically recognized. So we inserted 2 contactors, and if we copy one of the circuits, we can see that the 2 lines will be added, and on the elements Q11 there will be a Q12 and Q13. On the other hand, for the component number 1, we still see only A1, meaning that from the 4-volt actuator on the KNX device there are 2 free channels, and those will be applied into the representation here. So if I extend my sheet also with the KNX devices, then we can also visualize the KNX devices as equipment into the overview. So let me show you this A1. So the A1 component is now inserted here, and we can see the cross-reference to the circuits which will which I now used on sheet 55C, including with the KNX devices. So also on the single sheet we have the reference to the 71A, 71A. Now if we add another circuit of this, if we now add the new circuits, we can choose from our user-defined macros. We can choose the manual input, and within this manual input we will have the questionnaire for the circuit breaker, and we will also have automatically the questionnaire for the KNX device. So right now there will be a second KNX device created, and also there will be 2 contactors created from the inserted layout. So we can see the A2 component is generated here without a cross-reference, and if we now go to the KNX overview layout, we can insert not only the A1 but also the A2. And right now also this cross-reference to the sheet number 35 is handled exactly the same way we do here. Now for the components Q14, we can include that contact in one of the other light circuits. So from the component F6, we would like to have a new component based on one of the Q elements of one of the contactors. So if we choose the Q14, we can insert this one, and because of the numbering we can already see that this is forgiven. So we take another one, let's see this one, and we will insert also the contactor itself to the corresponding circuit. Selecting the elements with the macro option, we can edit everything we would like to influence. Now, if we come back to the layout of the board, this was set up initially, but right now we have more components. The components can be placed automatically or they can be placed manually. So if we have a default setting for the KNX systems, we have the A1 component, we have the A2 component, and they can also be drawn. Because of the option right here to have the next component, we can start drawing the elements, which are now included in here. We will also have, for example, the fuses. So at the end we had the F12, F13, and also the F14. So this can be set up quite easily, and by regenerating the circuits, also the overview from the inlay of the distribution board will be visible automatically accordingly to the correct numbering. So from the main distribution board setup in our plan, we changed the cable number 4 or circuit number 4. Now if I would like to do changes in this main distribution board, so I will go to my settings, and now circuit number 4 will be selected as circuit with a different naming. I would like to renumber. So for example, the parts from here to here, they will be cut and they will be placed in top of here. So right now we have a complete different overview of the circuits, and with my circuit tools I can renumber all circuit at once. Or I can also say I would like to renumber all cables, or I would like to renumber all fuses starting with the number 100. So all of the components which are now influenced on these settings will be updated not only from the distribution board itself, but they will also be updated from the plan itself. So if we go to the 2D plan, we can now see that this cable has a different circuit numbering. And we can also see that the cabling here will have a different circuit right now for the sockets. So this is one-to-one related to what we have in the single line diagram. So the updated layout, and if we enter also the terminal list, then we will see that all terminals are generated on the next one. So this is a terminal overview, and if I can check whether all terminals are now included, I can also say from one of the circuits, so from the top row circuits, we would like to have a different terminal. So instead of the X1 terminal, we would like to start with an X2 terminal, and we can also renumber starting with a new numbering for the selected terminals. So right now this is starting from 1 on the selected terminals. Let's see, we can have this unselected. So the update has been done on the terminals, so there will be a split for the X1 right here, starting with 1, 2, 3, 4, 5, and starting with the X2, which is included in here. So we can decide to have the phase counted, and we can also choose to have also the neutral counted simultaneously. So the link between the automation plan and the actual plan we have in 2D, means we can either start from the layout of the distribution board itself, or we can start planning from the model. The advantage for the layout of the distribution board itself, meaning that we can have influence for the entire loads which are connected to the distribution board. So if we look to the light circuit we inserted in right now number 8, there will be a load of 2.4 projected on phase 2 only. Now if we go to the overview of the single line diagram or the multi-line diagram, we can see that the load of this complete distribution board is 51.3 kilowatts, meaning 74 amps. But if we investigate a little bit further, we can see that we have a 74 amps on phase 1, but we have a lower load on phase 2 running, and even the load on phase 3 is nearly 30 amps less than the load on phase 1. So we have a possibility to optimize the overview for using phase distribution. So the phase distribution, meaning that the cable which is coming here as a load of 74 amps is now projected onto the load of the main distribution board. So for the main distribution board, we can do the same thing for the sheets. So if we insert single line diagram, we will also have the overview of the sheet in relations to the circuits which are connected. So we will generate the circuits automatically. So right now the 74 amps on this board is directly related because of the connections to the distribution board. And this is the reason why we have the device for the fuse in red, because the nominal is set to 16 amps initially, but afterwards connecting to the distribution board inside the offices, inside the connections for the sockets, we end up on a load of 74 amps. The 74 amps together with the 16 amps includes results in a 19 amps load for a fuse which was initially set up to 20 amps. So the red means pay attention to the situation. Because of the connection of the loads, something needs to be done or something needs to be decided. Now we can influence this on different ways. If we go to the main sheet here, we can first of all use the function for phase distribution. And the phase distribution can be done on phase 1, 2, 3, 1, 2, 3 in a single order, or we can also base this one on the amps itself. So right now I applied the phase distribution, which resulted into a maximum load of 15 amps. Now from the 50 amps going back to the single line diagram, we will see the loads end up here, meaning if I go to my overview, then I can choose to have the option, say, update components dimension. Then automatically based on the settings on the 50 amps, DDS will give you the option to have a 50 amps fuse. Now in the same way we can also optimize and update the components right here. So based on a 66 amp loads, then the proposition from DDS will be 80 amps fuse inserted here. So this is automatically updated onto the diagram, and right now here it's quite easy to see, if we represent the connections, that this is a connection as a supply in from the grid, and this is the sub switchboard connection. Now as a final step for the distribution board overview, we can see that we are working for each of the circuits with a load of 16 amps, but also a diversity factor. So if I would like to have all my sockets running on a different diversity factor, we can edit the component and we can say, well, we would like to have 35% of the load calculated forward. So right now, instead of the 50 amps, we end up with 39.6 amps. And maybe if we also influence the light circuits, by editing them to 50, then we will end up with a load of 34.6. So right now, if we now update the elements and the components right here, so instead of a 63 amps, which is also included for the cable and also for the calculation, we end up with a different setting. And now things are going back to the situation that if we use the option right here to update all components, so for this one and this one, then we will optimize our system. So instead of a 50 amps, we can go back to 40 amps. And if we look to the loads in here, we can see that the rating on the distribution or in the phase shifting is represented like this. So the reuse of distribution boards, so if we have a distribution board set up, I'm now switching to the plan and get a notification about this. We can see that the actual cable is being drawn from this element to here. So right now I will move this cable into this position and delete the cable, so it will be inside my my cable duct right here. Every change or every difference, so for example, if we move this socket half a meter, then not only the socket will be moved, but also the cable length will be increased. So every change will interact with the model plan in total. Now, if we set up a complete distribution board, as we did for the layout of this board, we can also insert the entire board, including with all sheets, into another model. So right now, what I'm going to do is I'm inserting another board into the same project. So one of my users created a model 500, which is also an electrical model, and I would like to insert this model into my my project on the number 5, meaning that from my overview of the main distribution board and my data rack, there is also a model 505, including with all of the sheets which are inserted in this project. Now this is a more industrial automation in which several components are created with DDS. So there is a generator, there is a connection, and all the components, as we can see, are also defined from DDS from the circuit list. And this can be done a circuit list not only for low voltage or for current distribution or phase distribution, but this can also be used for connecting with digital input and output. So for example, we have a setting on 16 amps digital input, and those digital inputs are referenced on one of the sheets. So if we can see to page number 10, 7F, we can follow the cross-reference to this sheet. So the sheet will be opened, and we can see the different digital output cards. And this is directly created from the model. So if we have the overview, we can see the different settings without cables, because this is about industrial, about the industrial part. So running from the industrial part on PLC, we can say we would like to have a 4-volt digital in, and within this component the module itself will be chosen, and also the components for the digital input cards will be chosen. So if we have from the database different settings, we can also have my digital input 1, digital input 2, digital input 4. That's why I didn't choose to have a 16-volt. Now this component is added in the bottom of the screen, meaning that we can put in the components On the last part, so this is a digital input. We can draw, we can place it here, and with the connection possibilities we can also have the settings connected to the connection line, which will automatically create a joint. If we move the joint, then also this will be selected from the component. Now, the digital 12 input was the component on Z28. Now, if we look to the overview on Z28, we can see that the naming of the digital input could be something else. So this is our motor export setting on type 2, like this. Export setting on type 2. So this is one-to-one related to what we have into the diagram. So also the PLC card will be listed in here, and if we go on into this model, we can see that from the automatic part, all the information is still available from the circuit list and connected to each other. So not only for housing, but also for industrial, we can have quite advanced options integrated into DDS. Well, this brings me to nearly the end of this second webinar. We saw advanced functions for making connections from the plan up to the automation. And also this webinar will be recorded, will also be available afterwards